Hi, everybody. Thanks for joining. We're going to get started. So the title of our session today is How Companies like OpenAI Ensure Their LLMs Are of High Quality. We're going to go through a lot of details about this, so hope you're all excited. Right, so my name is Marina. I'm an applied scientist at Twitch, or Amazon. I got my undergraduate degree at UC Berkeley and then my master's degree in Berlin. I started my career in statistics at a statistical consulting firm in Germany. And for the last few years, I have been working on machine learning problems for Coursera and now at Twitch. Most of my work has been focused on building production ML pipelines and then doing also some statistical analyses and that kind of thing. And lately, a lot around LLMs. I also work as a data science mentor for people who are just trying to break into the field and as a pro bono consultant for like nonprofits and that kind of thing. I really love teaching and helping people get started in this field. It's super interesting, super challenging. There's a ton to learn, but it can be super rewarding. So here's our agenda for today. We're going to start with just a very high-level introduction to large language models. We're not going to get into any of the details on training or fine-tuning or anything like that, but more just conceptually, what are LLMs? We're going to talk about performance evaluation also at a high level, the different kinds of performance evaluation we might want to do. We'll talk about how we can evaluate LLMs using supervised techniques, just like any supervised machine learning. We'll do a little interactive demo on using standard metrics to evaluate LLM performance. Then we'll dig into some of the advanced evaluation techniques that are really specific to LLMs in particular. We'll talk about a case study of how OpenAI used these techniques for GPT-4. And then we'll talk a little bit about future directions and challenges. So the meeting invite goes till 6, but we're actually planned till 6:30. If you need to drop, no worries, but just a heads up, we might go a little bit past 6. If you have any questions along the way, please feel free to use the Q&A feature too. So to set the stage a little bit, what is the context that we're working in here? So these days, companies across industries rely on LLMs for a lot of different user-facing applications, right? So we have chatbots, content generation, code assistance, all kinds of things. Since users are interacting with these LLMs directly, the quality of the model can have a really big impact on user satisfaction, and that can impact things like brand reputation and even the bottom line. So poorly performing models can lead to customer frustration, legal issues, financial losses. It's a really big issue. So for teams that are working on integrating LLMs, we need robust evaluation metrics that ensure that our LLMs are meeting the requirements that we have. So this is both before and after deployment, something we need to worry about in order to reduce the risk of errors or unexpected behaviors in production. Learning how to evaluate these models is going to help you to avoid those costly mistakes and also contribute to safer AI and also help you develop skills that are really useful in the job market these days. So there are lots and lots of different approaches to evaluating LLMs. Today's presentation is pretty high level. So the idea is more to introduce you to what's out there. We're not going to dig into the mathematical functions for anything like that or get into really the nitty-gritty, but we're going to talk at a high level conceptually about the different approaches that exist and hopefully give you some inspiration for things you might want to dig into more detail on your own. We'll learn enough, though, to be able to understand papers from companies like Google and OpenAI that talk about how they evaluate their models, and we will go through some of these details when we're talking about the OpenAI case study. So like I mentioned before, if you have questions, feel free to use the Q&A feature. I'll try to get to as many as we have time for. Sometimes I might have to move us along if time is an issue, but I'll do my best to get through as much as I can. All right, so let's start with an introduction to LLMs. As we all know, these models have really revolutionized the field of natural language processing and many other downstream applications for a wide range of applications. LLMs are a type of machine learning model that's specifically designed to understand and generate human-like text. So these models are trained on tons of data, so sourced from the internet, books, articles, other text resources. And then this training is done using neural networks, so deep learning models that have many layers, and this allows the models, the large language models, to learn complex patterns and relationships in that text data. The depth and complexity of these models then allows them to capture nuance in language that some more traditional NLP approaches weren't able to do. This also allows LLMs to be really versatile. So they excel at a large variety of language-related tasks like translation, summarization, question answering, creative writing, all kinds of things. They're able to comprehend text and understand these nuances, which allows them to generate responses that are not only coherent, but also contextually relevant. And this is what really makes them so powerful in applications like chatbots, virtual assistants, content creation tools, lots of stuff that's super user-facing. There is a lot of work going on right now in the LLM space and lots of players in the field. You've probably heard about all the biggest ones. We have OpenAI, there's Gemini from Google, Llama from Meta, Azure's OpenAI, and maybe even the Claude models from Anthropic. So these are some of the most popular, but there are many, many others. To kind of set some context for what we're going to be focusing on today, let's take a look at the LLM lifecycle. So the first step, like with any machine learning problem, is data collection and data pre-processing. LLMs require a ton of data. And so this is gathered from really diverse sources, like I was saying, books, websites, internet articles. And this raw data all needs to be prepped. So there's a pre-processing step to clean and format it. This is going to help remove noise and ensure consistency. And then once the data is prepared, we can actually train the model. So this involves using deep learning algorithms to train the model on that pre-processed text, which helps the model to learn those patterns that can teach it grammar, context, and nuances in the language, which then allow it to generate that human-like text. After the initial training, the models often undergo fine-tuning. So this stage involves further training the model on a smaller, more specific data set, which can help it refine its performance on specific tasks. This really just tailors the model's responses to meet specific needs or improve accuracy in specialized areas. Our focus today is going to be on the evaluation stage. Evaluating LLMs is really important to ensure they perform as expected and they're safe to use. Evaluation involves many metrics and tests, lots of different approaches for getting an understanding of the model's accuracy, coherence, relevance, and even bias. We're definitely going to spend a lot of time on all of this in a little bit. Once the model has been trained and evaluated, it moves to deployment. This stage involves integrating the model into applications or services where it can be used by the end user. Monitoring is really critical here to make sure that the model is performing as we expect in real-world scenarios and ensure it continues to meet those requirements over time. So this kind of final step in the life cycle is maintenance and updates. As new data becomes available and user needs evolve, the model needs periodic updates and maintenance to ensure it remains effective, up-to-date, and aligned with current standards and expectations. So keep in mind that, like any machine learning model, this is an iterative process. So we're not done after we've deployed. We're always going to be continuing to work on the model over time. Let's talk a little bit about performance evaluation. There are lots of reasons we'd want to evaluate the performance of an LLM. First, organizations need to be able to see how well an LLM does on a particular task. So this might involve comparing the performance of multiple LLMs to pick one, or maybe it's a final evaluation of a fine-tuned LLM on a specific task. Bias detection and mitigation are also really important. LLMs can carry bias from the training data that they were trained on. And so a thorough evaluation framework can help us to identify and measure those biases so we can hopefully mitigate them. Finally, we also need to make sure that we're evaluating user satisfaction and trust, because this is really important since, like we were saying, these LLMs are often used directly by end users, and it's important for their acceptance and successful deployment that customers are happy with them. We can think of evaluating LLMs in two different ways. We can think about system evaluation and model evaluation. System evaluation focuses on the components within our control, like prompts and context. This type of evaluation measures aspects like input-output determination efficiency, model perplexity, and retrieval relevance. We'll talk a bit about these in more detail soon, but essentially what we're looking for is how well the system performs given specific inputs and some settings that we can manipulate directly. In contrast, model evaluation focuses on the raw capabilities of the model itself. So how well the model itself is understanding us, generating and manipulating language within the appropriate context. And this is all independent of the surrounding system or application-specific settings. In other words, basically, the aim is to gauge the overall performance and intelligence of the model across multiple tasks, independent of the system that it's embedded in. So let's illustrate this with an example. Imagine you are deploying an AI-powered chatbot, and this is going to be used for customer support for like a large e-commerce platform. For system evaluation, the focus would be on how well the chatbot handles specific customer queries based on predefined prompts. So you might evaluate how efficiently the chatbot guides a user through the process of returning an item. This might involve tweaking the context, guiding the conversation through multiple steps to ensure the chatbot provides accurate and relevant information in different scenarios. And here we would use metrics like relevance of the retrieval, input-output determination efficiency, that kind of thing. In contrast, if you were evaluating the chatbot's underlying language model before integrating into your system, this would be model evaluation. In this case, the focus is on the raw ability of the model to understand and generate natural language across a variety of topics, like how well the model can understand diverse customer questions or generate contextually relevant answers in response to whatever the query the customer might have would be. This doesn't consider specific prompts or the conversation flow that you're going to introduce later. And so here we can use automated metrics like Rouge or human evaluation to gauge the overall language competence of the model. We have many, many tools at our disposal for these tasks. So for example, we have some automated metrics, like I was mentioning. We'll talk about those next. So these are metrics like Blue, Rouge, and Exact Match, which can be used to measure the accuracy and quality of the outputs in both system and model evaluations. In system evaluations, these metrics help determine the effectiveness of prompts and context. And in model evaluations, they assess the model's raw ability to generate accurate and coherent language. This is basically like supervised learning like you're used to with any other machine learning model that we'd be familiar with. We also have benchmarking, which involves evaluating models on specific tasks with predefined metrics, which allows us to kind of rank and compare different models with like a set specific task. Of course, we always have human evaluation, so just using human judgment to evaluate the quality of the model's outputs. This is, of course, considered the gold standard, but of course, it's time-consuming and not necessarily super scalable all the time. So we might use human evaluation in a system evaluation in order to improve the prompts and the context settings. And in model evaluations, we could get just insights into how well the model performs, independent of the prompts that we might use. Since human evaluation isn't always super scalable, we can also use an LLM as a judge to judge another LLM's outputs. So we're going to talk about this a little bit more in a little bit as well. So this is a good balance between scalability and nuanced assessment. And finally, we can use online engagement metrics. So just how do users enjoy interacting with the LLM based on how they interact with it? Like, do they bounce a lot? What's their click-through rate? What's any kind of like, net promoter score or something like that? There are many evaluation platforms that allow us to use automatic evaluations across many of these different phases. So we can have one place where we can do end-to-end testing using many different options, depending on where we are in the LLM lifecycle and our kind of balance between scalability and the, I would say, how important the outcome is. So in some cases, we have a model that's used for really critical things. And in that case, we might want to have like human evaluation, or if it's less critical, we could use something like LLM as judge or automated metrics. So we can really create a streamlined evaluation workflow with a lot of different options using these platforms. There are tons of things to consider when we're evaluating LLMs. So it's really important that we tailor our evaluation criteria to our specific application. So the first thing we could think about is task-specific criteria. So this includes evaluating the model on specific tasks, like if you have a model that's supposed to summarize or do something like named entity recognition or retrieval augmented generation, question answering, etc. Each task has its own set of benchmarks and metrics that can ensure the model performs well in those particular domains. So for example, if we were deploying an LLM to perform summarization for news articles, we would focus on its ability to accurately condense information and retain key points. So it makes sense, really specific to that task. We would also think about responsible AI. This is making sure that the model conforms to ethical guidelines, respects privacy, and avoids any harmful behaviors. So this is super important in applications like content moderation, on social media platforms where the AI needs to avoid any kind of harmful behavior. And then, similarly, if we're creating a model that is going to be used for something like a loan approval process, then fairness would become really important, which is our next point. So we need to make sure that the model treats all groups equitably and doesn't have any inherent bias that's going to harm our end users. Robustness talks about the model's ability to perform reliably under different conditions. So, for example, if we had an autonomous driving system, an example of robustness would just be the AI robust enough to handle like diverse and unexpected scenarios on the road. Or for an LLM, we might think about very, very short prompts, very long prompts, prompts in different languages, prompts with various images, different kinds of text. How well can it perform under many different scenarios? Factuality is really important for applications like education tools or legal advisors, where we really need to make sure that the LLM is producing accurate information. Speed and cost are, of course, very important in all deployed machine learning models. So if we have something like a real-time application of a customer service chatbot, we need to make sure that the LLM can respond quickly and generate responses with a reasonable amount of computational cost. We also kind of have this bucket called quality, which is kind of the overall performance of the model. So if we have, for example, like a creative writing assistant, we would prioritize things like fluency, coherence, and the relevance of the generated text to the prompt. Lastly, of course, we want to make sure that our LLM is consistent and can generalize well to a variety of different scenarios. So an example here would be, imagine we have like a healthcare diagnostic tool. Models should consistently perform well across different medical cases and be able to generalize well from its training data to new unseen patient data pretty effectively. So as we can see, there are lots and lots of different things that we could potentially consider when we're evaluating a large language model. So it's going to be really important for us to tailor our evaluation to our specific application. And this is going to be one of the key things for knowing if our evaluation is good, because we could create an evaluation, but how do we know if we're evaluating the right things for our problem? So of course, like we were saying, we want to focus on the most critical outcomes for the application. So we need to identify the key goals and objectives the model needs to achieve, and then tailor the evaluation criteria to measure those specific outcomes. So for example, imagine we have a company that's developing an LLM app. Again, let's go with customer support responses. So the evaluation should focus on the most critical outcome, which in this case is going to be customer satisfaction. We could assess this by measuring how accurately the model responds to customer inquiries. And then maybe if we have some kind of data on overall sentiment based on the responses, like maybe there's a little survey or something after the users are done interacting with the chatbot, we can use those as our primary metrics. We also need to make sure that we tailor our metrics to a small number that are easy to interpret and to understand. Super important that we don't overcomplicate things with too many metrics that makes it difficult to get a clear picture. So for example, if we continue with the example before, we choose something like maybe one automated metric, like Rouge for response accuracy, and then maybe human sentiment scores. And that's our two main ones. And we wouldn't try to overcomplicate things with many, many different metrics. The evaluation process should also be fast, reliable, and automatic to compute ideally. So this ensures that we can frequently get an understanding of how well our model is performing. And also, of course, not use too many resources. So for example, maybe we could have a pipeline for our metrics that runs reports regularly. So if there's like a little automated survey, we're just going to have some kind of ETL pipeline that gets that into a dashboard or notification in some way so that we have some understanding of how well our model is doing automatically and quickly. It's really important that our testing is also done on data sets that are diverse and representative of real-world scenarios. So maybe we just have a random sample of customer inquiries to take our metrics from, for example, so that we have a good overview. Like we wouldn't want to just take metrics from a specific geographic location or a specific time of day or specific kind of inquiry. We want to make sure that we're getting a representative understanding of how our model performs across many different problems. It's also important that our metrics are really correlated with human judgment. So if I, as a human, see an LLM's output, I should pretty much agree with however the automated metrics are judging it. If the metrics say it's really great, me as a human should also read the response and be like, yep, this is really great. It should just align intuitively with what we would expect. And this is obviously important because the people who are using these models are humans. So we need to make sure that they're happy with the end result. Lastly, we need to make sure that our evaluation framework enables monitoring score changes over time. So this can allow us to have continuous improvement, spot trends, notice if anything is wrong, and be able to integrate that into our model pipeline for ongoing performance review and feedback. I just want to pause for a moment. If there are questions, please feel free to use the Q&A function. Even if I'm talking, I'll try to get to them when I'm done with that section. So yeah, feel free to add any questions in there if you have any. So next I'm going to talk about supervised LLM evaluation. So we can evaluate LLMs in the same way as most supervised models. So for anyone here who might not be familiar with supervised versus unsupervised learning and machine learning, basically what this means is we know what the right answer is, and we can compare our response to that right answer. We have labeled data. So because we can do this, we have a lot of options at our disposal. We can use normal classification metrics that we're all used to in the machine learning world, but we can also use some specialized metrics. And so we need these special metrics because capturing linguistic nuance is an extra challenge that we have to deal with for LLMs, and it's really important for evaluating their quality. We also need to make sure the LLM understands context and that the output texts are high quality as well. So we need to think about things like fluency, coherence, relevance, many different options for things we need to consider with LLMs that we don't necessarily need to think about when we're doing something simple like text classification. There are also some unique challenges for LLMs. So we might have ambiguous inputs or subtle context shifts. We might have to deal with bias in the training data. And we also need to understand that LLMs are obviously operating in a really large scale kind of environment with complex inputs and outputs. So we have to have really robust evaluation frameworks to handle this complexity. So like any supervised learning problem, we need to have a labeled data set. The first step is to build this data set. So we want to have a diverse set of inputs that cover various scenarios, topics, and complexities. This is going to help the LLM to generalize effectively. As long as it's seen many different options in training, it's going to have a better job, or going to do a better job at generalizing in the future. And then we need to gather corresponding high quality outputs to establish ground truth. So for example, if we're doing summarization, we might get a diverse set of texts that are representative of the texts we're going to want to summarize. And then we might have human annotators create summaries for us. And that can be our ground truth or gold standard data set. Obviously, this has some scalability concerns. So another thing we can do is leverage the capabilities of LLMs to generate their own evaluation data sets. So we should still make sure there are humans in the loop somewhere along the way, especially while we're kind of creating the pipeline to generate these LLM generated summaries. But this can be a good way to enhance the scalability and get that balance right. Once we have a data set, we can approach the problem just like any supervised learning problem, just with some new metrics. So we still have our classification metrics that we're used to, and then we also have some new ones. And these fundamental metrics can give us a good quantitative measure of the model's performance and help us understand strengths and weaknesses. So let's dive a little deeper into each one. And actually, before I get started on that, I see a question. So can you provide an example of how the LLM can help with data labeling? Yeah, so imagine a scenario where I want to build a model that is going to be a text classification model. So it's going to look at tweets, and then it's going to say, are these positive, negative, or neutral, let's say. So this is pretty simple, but what we could do is we could generate a labeled data set using an LLM that has been fine-tuned on this specific task. So we would say, here, given a small set of labeled data, learn how a human would respond to these various kind of sentiment classifications. and then generate additional labels. And then those labels can be used to evaluate the performance of the LLM that we're using for classification. So there's an extra step in there where we need to have a fine-tuned model or a model that we're very confident in to generate our labels. But once we have that, then evaluating the primary model that we're using for whatever our end task is, like summarization, classification, becomes a lot more scalable. And we're actually going to talk about how Meta is doing this pretty soon too. That'll be one of the examples later on. So for NLP classification tasks like sentiment analysis, like we were just chatting about, we can use typical metrics like precision and recall to measure how well our model performs against a labeled data set. So let's keep going with this tweet sentiment analysis one, because that's what we're going to do in the demo. So given that example, for anyone who might be unfamiliar with these metrics, let me give a little overview. Precision says, of all the cases that the model classified as positive, what % actually were? So in this case, out of all the tweets that we predicted to be positive sentiment, what % actually had positive sentiment? This is something we would use when we really care about false positives, when the cost of false positives is high. Recall is, of all the positive cases that exist in the data set, what % were identified by the model? So of all of the tweets in our data set that were actually positive, what % did the model correctly identify? This is good when the cost of false negatives is high. We can use F1 when we care about both false negatives and false positives. So this is just the harmonic mean of precision and recall. And accuracy is just, plain and simple, how many did we get correct? What % we got correct? This is not often used in real life because it only is really logical when we have a balanced data set where it's like 50% positive and 50% negative, and that's very rare in real life. So this is something that's more kind of like, it's an option, but not something that is used as much as precision or recall. Okay, but we know LLMs do a lot more than simple classification. So we need some new metrics. The first one we're going to talk about is perplexity. Perplexity measures how well a language model predicts a given sequence of words. So it's basically the model's ability to predict the next word in a sequence based on the words that have come before it. Lower perplexity is better model performance because the model is less perplexed or less surprised, you could say, by the test data, and the predictions are more accurate. Higher perplexity is worse performance because the model is more surprised by the text data, or the test data, excuse me. So it's like less accurate in its predictions. Concretely, if we think about this, if a language model has a perplexity of 50, it means that on average, it is as uncertain as if it had to choose between 50 different possible words at each step. So if the perplexity was 2, the model is just having to pick between 2 words. That's pretty confident. It's a pretty good chance. If the perplexity is 5,000, the model is super confused. It has no idea what to pick next. It could pick any of these 5,000. It's really not narrowing in on what it needs to say next. So an advantage of perplexity is it's straightforward, widely used. It's a really simple quantitative measure of a language model's prediction accuracy, makes it really easy to compare the performance of different models. And so this is a really accessible model for initial assessments of language models. But there are some limitations. So for example, it doesn't capture the model's understanding of context, coherence, or relevance. So it could be that you have a model with lower perplexity scores, but it's still producing outputs that just aren't contextually appropriate, they're not really relevant, or they just don't sound very good. That could completely happen. And we also could have problems if we over-rely on perplexity. So it doesn't reflect real-world performance on user satisfaction, for example. We could have a model that scores really well on perplexity, but it doesn't perform very well in practical applications where we need nuanced language and that kind of thing. So it can be a really good fundamental starting point, but it shouldn't be the only one that you use. We also have BLUE, which is a metric used to evaluate the quality of machine-generated text, also by comparing it to some reference texts. So this is very commonly used for translation, but it can be used for things like image captioning or code generation as well. BLUE is basically precision. So higher BLUE scores are going to indicate better quality text. because the model's output is closer to the reference text. If we had a blue score of 100, that means the model's text is identical to the reference text, and a score of 0 is they're completely different. So we calculate this by determining n-grams of various lengths. So an n-gram is like a bigram is 2 tokens. You know, you could have a unigram, just 1 token. So we have these different kind of lengths of chunks of text, and we compare those. And then we try to get the precision from that to calculate blue. So we also have a little bit of a penalty for brevity because we want to penalize candidate translations that are really short. So there's a couple different things that are involved in the actual calculation, but the key thing to remember is blue is basically your precision. Some advantages of blue are, again, it's widely used and accepted in the industry. It's a quick way to measure the text, the accuracy usually of a translation, but you know, of any kind of these like machine generated text options. And it's just standardized, consistent, and fairly good to use when you have different systems and you need a quick, easy way to measure precision. But of course, it also has limitations, just like perplexity. So it focuses heavily on exact word matches, which means it can miss context and the semantic meaning of text. So you could get like very high scores for text that's syntactically correct, but it doesn't have a lot of contextual accuracy. It can also penalize different word choices that might still be correct. So it's not really great if you care about paraphrasing or rephrased content, because it's really looking for those exact matches. And it's, again, not always going to reflect human judgment on text quality. So humans are going to appreciate that nuance and context that the metric is going to overlook. So while blue is our version of precision, rouge is our version of recall. So this is also measuring the quality of text, for example, summaries, compared to some reference text. So in this case, we're focusing on the recall of n-grams and longest common subsequence. Just like blue, higher scores are better performance because it's showing that you have more overlap with the reference summaries. So we have a more accurate, comprehensive summary typically. So we have many different kinds of rouge. So there's a couple different flavors. We have rouge N, rouge L, rouge S, and a couple more, I think. So there are different ways of calculating the same idea. These are all going to get you some form of recall, but just different kind of parameters there. So you might have with rouge N, for example, n-gram overlap, or with rouge L, longest common subsequence. So many different options depending on your use case. So one of the advantages of rouge is that we have, similarly, a simple, accepted, easy to measure kind of way to get at recall in particular. And this can also be used for various tasks in natural language processing. So it doesn't have to be just summaries, lots of different things you could use this for. Of course, it has limitations just like all the others. So it's going to focus really on that surface level similarity. And it's, again, going to overlook deeper semantic meaning. This can result in penalizing summaries that are creative, but maybe not super valid paraphrasing, or maybe they are valid paraphrasing, but it's just too creative for the model to understand. We also need to have reference summaries, just like with all of these, we need to have a labeled data set. So that can also be a challenge. So just to recap, the difference between blue and rouge is blue is going to check how much of the machine generated text matches the reference text, while rouge checks how much of the reference text is captured by the generated text. So precision and recall. Okay, I see a question here. Are there automated tools available to test LLMs? There are tons. So we'll talk about a couple of specific ones. There's benchmarking, there's automated platforms, there's libraries, which I'll show in the demo right now. So tons of options for you. You don't have to like calculate rouge manually by hand or anything like that. Okay, we're going to get into the demo now. So we're going to just do a demo on some of these kind of like fundamental metrics that we can use supervised evaluation for. Let me just pull up the code. All right, just a moment. get it so that I can see your questions if you have any. Okay, cool. So the first thing we're going to do is just import some libraries, right? So I'm going to use a model from OpenAI for this. So I'm just importing OpenAI, and then I'm using Colab. So, just some like Colab stuff so I can access data. I'm using a tweet sentiment analysis data set from Kaggle. So I'm just going to read that in. And then let's just take a look at the data. Let's just take a look at the first few rows. So we can see we have an ID field, a text field, and then a sentiment field, and then a bunch of other stuff that we're not going to use right now. So time of tweet, age of user, country, all kinds of stuff. We're only going to use the text and the label. And then also you'll see we have neutral, negative. There's also positive in here. So we have a neutral category, but in the interest of simplicity, we're just going to keep positive and negative. So I'm going to go ahead and filter the data set to only contain these positive and negative tweets. Then what I'm doing here is I'm getting the OpenAI API. I have my little API key stored, and then I'm going to use the GPT 3.5 Turbo model. So let's take a look at a single example. So let's say tweet equal to sentiment text. Let's just grab the first value. Okay, so this person is really sad that they're going to miss someone in San Diego. So we're going to assume that this is probably negative, right? But let's double check. So let's see. What do we have there? Yeah, negative. So that makes sense. So what we're going to do is we're going to pass this tweet text into this prompt. So we have this full prompt here, and it just says, so given the text of a tweet, classify it into either positive or negative sentiment. Return only the string positive or the word negative with no other explanations or extra text. Then we're just using f strings to pass in the tweet, and then I'm kind of prompting the LLM to return the sentiment by having the sentiment there. So this is a zero-shot prompt. I did not do any work to fine-tune this prompt or anything. It's just a very simple prompt. And then what we're going to do is it's going to pass this text into the full prompt, and then we're going to put this full prompt into the completions. So this is just the format that you need to work with the OpenAI API in particular. Every API will have a different format, but basically what we're doing is we're defining the model here. So we have this GPT 3.5 Turbo, and then messages. So we're having the system context. This is just saying you are a helpful assistant, which is basically like the default kind of role that a model like this would expect. But I could also say like, you are a mad scientist, and then you could see how it would change things. We're just going to keep it simple for now. And then we're going to send in the prompt in the content. So let's see what it does. All right, I've run this, and now we should have something in the completion. So let's see the full completion here. So we have an ID, we have choices, a whole bunch of different parameters here, the model created at, all kinds of stuff. So we don't actually need all of this, right? We're just going to want to have the actual response from the model. So we can do completion dot choices. I'm just going to grab the first choice, and then message content. So negative. The model correctly identified that this tweet, so sad I'll miss you in San Diego, has a negative sentiment. So the next thing I'm going to do here is kind of just expand on this a little bit and run a bunch of examples. So we're going to run 20 examples. So here I'm just saying we're going to create an empty list for the classifications, and all of the tweets in the first 20 and the sentiment data frame that we have here. It's the exact same prompt and the exact same completion. So let's just run that. And it's a little bit slow, which is the thing about LLMs. They can be a little bit slow. And then we're going to grab our true labels. So true labels. And we know we're taking the first 20 because that's what we did here. So we were grabbing the first 20 tweet texts, and now we're going to grab the first 20 labels. So let's see how well the model performed. We have precision, recall, and F1, like we talked about before. So as a reminder, precision is going to say, of all the tweets we predicted to be positive, what % actually were. Recall is of all of the positive tweets in this 20 tweet data set that we have, what % were identified correctly. And we have F1, which is just the harmonic mean between those two. And we don't need to calculate these manually, so we can import them from sklearn. So we're just saying from sklearn.metrics, import precision score, recall score, and F1 score. Then, if you recall, I put the classifications here in this empty list. And the true labels are just the first 20 values. So we're calculating precision score with the true labels and the classifications. Let's see what we get. Oh, I guess it makes sense to import those libraries first. Yep. And it is perfect. Unsurprisingly, this is a very easy problem. I actually tried to find an older LLM that would do a worse job as a better example here. But this is the oldest one that's available, easily on OpenAI's API right now. They don't have any like GPT-2 or anything. So what this is saying is, of all of the tweets that we classified as positive, 100% actually were positive. Of all of the positive tweets in those 20, the model correctly identified all of them. And then so obviously the mean is 100%. So I'm going to pause here. I see a couple of questions. So we have a question here. What does LLM stand for? So that's just large language model. That's all. And then how do LLMs like ChatGPT, Claude, et cetera, get access to vast data? So a lot of this is just public internet. They're just scraping everything from the internet or using publicly available data sets. And then some of it is like they purchase them. So they might purchase access to a special archival newspaper database or something. So yeah, they're basically taking everything that they can just from the public internet and then also buying access to other things that they don't naturally have access to from that. All right, so let's talk about some of the more LLM specific metrics here. So we have perplexity. As a reminder, again, this is basically how surprised the model is by each tweet. So we're going to want lower perplexity, just assume that the model found a better sequence of words. And then higher values would mean that the tweet's sequence of words were less predictable. So again, we do not need to calculate this manually. We can just pull this from the evaluate library. So we can just load that from evaluate, just perplexity metric. And then here I'm using a worse model just for interest of comparison. And then we're going to use just the first 5 tweets because this is a little bit slow. So once all that loads in, yeah, it has to download for a second. There's a bunch of stuff going on there in the background. Then we'll just give it a few moments here. We'll take a look at the results. Yeah, so we have our perplexity values. So we can see tweet number 1 had a perplexity of 176. So let's take a look at that. Just going to copy pasta this real quick. Okay, so the model wasn't super confused by that one. It kind of made sense, right? It kind of had an understanding. It only knew if there was 177 words that it would pick between, or 176. But then this one, we see number 3, here it was 1,800. So the model is way more confused by tweet number 3. So let's take a look. What interview, leave me alone? That is a lot less clear to me as well than the first one. So kind of makes sense intuitively here. We also get the mean perplexity across all of the tweets in case you want to understand the performance across your entire data set and not just a specific example. We can use blue for measuring the quality of machine-generated text by comparing it to reference texts like we talked about. So we want higher blue scores. So we're perplexity, we want lower scores. Blue and rouge, we want higher scores. Just like before, we do not need to calculate anything manually. We can just use the blue score from NLTK. So I have some examples here. So these are some reference texts and then machine translations. So this would be the original. This is a classic little sentence. The quick brown fox jumps over the lazy dog while the energetic cat runs under the swift bird. And so if we were to translate it, let's just say that the reference to the original was in a different language, and then these are all translations. So our references are correct translations. And then our machine translations are just like, let's say an LLM generated these for the purposes of, kind of looking into how this would work. So we can go for each of these machine translations. What is the blue score? So the blue score thinks that this third machine translation is the best one. So it thinks the swift brown fox jumps over the lazy dog as the energetic cat runs below the swift bird is a better translation than the fast brown fox jumps over the lazy dog while the energetic cat runs under the fast bird. So it's like very similar, but it's saying that like in general, this third one here is a better match given these reference translations that we were using. So it's just a quick and easy way to get kind of an overview, a quantitative look into which of these is the best translation. Finally, we have Rouge. So this is going to be our recall metric. We're going to import this from Rouge score, the library. And here we're going to look at summaries. So let's say a reference summary, like the best possible summary would be the quick brown fox jumps over the lazy dog. And a candidate summary is going to be the quick brown fox leaps over a lazy dog. So it's very similar. Let's see what it says when we look at the different kinds of Rouge scores. So we have Rouge 1, 2, and Rouge L. Rouge 1 is measuring the overlap of individual words or unigrams. So in this case, we have precision, recall, and F measure of 78. Rouge 2 is the overlap of bigrams or pairs of words. So that's giving us precision, recall, and F measure of 0.5. And then Rouge L is the longest common subsequence. And here we're at 0.77 for all of these as well. So you can see that depending on what we care about, do we care about just recall of individual words? Do we care about longest common subsequence, bigrams? We're going to get different answers. But any of these could be used to compare multiple candidate summaries. So if I did a different candidate summary, the lazy cat, let's just say something completely wrong. Let's say the cute cat, so that it's very different. Now we're going to get, oh, yeah, makes sense. You have to pass it through. Very different values here. So this candidate summary 2 is obviously worse than candidate summary 1 because I've, completely changed these unigrams and then also the bigrams and the longest common subsequence. So we have different scores here. So that's all to say that all of these metrics are pretty easy to compute using existing packages. And then the automated frameworks that we can use can have many, many different metrics all automated for us. Okay, and I'm sorry, I missed a couple of questions here. I did not see them until just now. So can you please briefly share how to improve the performance of the model? I would say that's a little bit outside of scope for this class. In general, I will say just at a high level, in general, you probably don't need to fine tune a model. In general, if your model is not performing how you want it to, you probably just need to improve your prompt. That's my quick answer here. So yeah, prompt engineering can get you a really long way. It's pretty rare in my experience that you actually need to fine tune a model. And then will we be able to share a link to the Colab post session? Yeah, actually I can send a link to, the GitHub repo that has the slides and Colab. I can send both of those. And then how can we monitor LLM's quality post-deployment? Are there any tools for continuous monitoring? Yeah, so of course you could use any normal tools that you have for monitoring. You could calculate metrics like, like customer satisfaction. You have a little pop-up survey, you could calculate those metrics, you could send them to CloudWatch, right? It could be the same as any other machine learning model. But if you want to kind of look at the model performance itself, then there are frameworks like OpenAI's evals that you could use for that. Oh, last question here. Rouge here uses a word for n-gram, but LLMs work on tokens and not words in its vocabulary. That's true. How can you use the metric to compare LLM summarized texts? Well, I mean, it's still the output text, right? So we still as humans care about the words. So this is not about training the model. It's just about evaluating the model once it's already been trained. Everything here we're talking about is post-training. How can I see how well this model does on a particular task? So in the interest of time, I'm just going to move on, but please let me know if you have any other questions. And then here I will send the link. So let me know if you can't see that, but I've just sent a link to the GitHub that has the Colab notebook and the slides as well. And also I think the Kaggle data set too, if you wanted to run it on your own. You just need to get OpenAI keys for yourself, but that's pretty easy to do. Okay, I see one more question here. So if I want to build an LLM for my personal use, how will it gain the different capabilities of text summarization, calculations, etc.? So you should not make your own LLM. Like training one from scratch is not really feasible. You would need an incredible amount of data. You would need a ton of GPUs. It'd be super expensive, take forever, and there's really no reason to do that. So you would probably instead want to download a pre-trained model. So you could download the weights and use them locally, or you could just use an API like what I was just showing here with OpenAI. So those would be better approaches. It would not make sense to try to do this from scratch. It's probably too much for an individual. You need to be Google or Microsoft to be able to do this. Okay. How are the references or labels typically generated? Are they always done by humans? No. So you can. I mean, ideal scenario, you have an army of humans who all wants to help you, and then you can get perfect references. That's great. But of course, scalability is a factor. That's probably not going to happen. So what you can do is you can also use another LLM that's fine-tuned on this task to help generate those references for you. So you could have like a small group of labels that are or labels, references, whatever it is for your particular use case that were generated by humans. Fine tune or prompt another LLM to be able to generate those kind of similar quality references, and then use that LLM to generate references at scale. So that's definitely an easy way to scale this. Okay, we have another question here. So for roles that ask about LLM knowledge, how do you prepare for such roles? So always practice. Projects are always going to be the best way to learn anything. So I would say if you have a project in mind that might be interesting to you, something that's just like genuinely interesting to you as an individual, go ahead and build that from scratch. So again, I'm not saying build your own LLM, but build like an end-to-end application that's a chatbot, for example, using an OpenAI API or, an API from any other of the, big cloud providers, and then, deploy an application. And then you would have experience kind of figuring out what prompts work the best, how you're going to evaluate it, how you want to set up monitoring. That's definitely the best approach. There's also books and courses, of course, but I would always advocate for doing project-based learning as much as you can. Right. What are the use cases for fine tuning? So like I was saying, in my experience, I've actually never needed to fine tune. I'm not the world's foremost expert on LLMs or anything, but I've used them quite a bit, and typically you can get really far with clever prompting. So I'm trying to think of any use case for specifically fine tuning. I mean, I guess it would just be if you haven't been able to achieve the level of quality that you want from prompts alone. So if you're trying to, maybe it's something very specific to like the medical domain, for example. Maybe you're trying to create a model that can make recommendations for a patient. And so you can't really get where you want from just fine tuning or just adding, or excuse me, just prompt engineering or retrieval augmented generation and prompt engineering. Then maybe you would need to fine tune a model. So I would say maybe very specific domains or something that's very challenging. But for general use cases, anything with like summarizing, sentiment, that kind of stuff, not super relevant most of the time in my experience. Okay. How do you ensure LLMs used for evaluation don't introduce bias? So you would just have metrics for bias. That would be the easiest way to do that. There are plenty of automated tools that allow you to do that. So yeah, you would just basically have like an automated like benchmark suite or something like that. We're going to talk a little bit more about some of these advanced evaluation options. And so that would probably be the easiest way, is just make sure that you're not introducing an extra step that's going to cause downstream problems in terms of bias. Okay, one more question here, actually a couple more, two more. So how can I identify which pre-trained LLMs I could use for my needs? So I would say go to Hugging Face and then just take a look at the models that are available there. So Hugging Face is going to have a list of a whole bunch of models. Probably just go with the most popular one in the domain that you're interested in. So on like the left-hand side, it'll say or at least it was left-hand side not too long ago. It'll say like for question answering, for text completion, etc. It'll say like with the kind of use cases on one side, you select that and then just pick the most popular one, or like the most popular one that you can use on your machine if you have like resource constraints. That's probably going to be fine. Most popular, newest, probably going to be your best bet. Then apart from NLP, what other domains use LLMs? So lots of stuff. I mean, it depends on kind of like where you draw the line for NLP, but LLMs are also used for like code generation. They can be used for captioning images, all kinds of stuff with like, yeah, summarizing like images or video, kind of multimodal inputs can also use LLMs, but it's always going to have a text component. There, of course, are other Gen AI models that are not language models specifically, like, you've probably seen the image generation ones. So in that case, there's still like a text component, right? Because you're typing in your prompt and then it's creating an image, but it's not an LM specifically. It's like, more of a generative model for images or video data or music. Okay, so these standard metrics are a good starting point, but of course they can miss nuance. So metric like blue, like we were talking about, they're really commonly used, but they can often overlook context and semantics, that kind of thing. So it's really important that we have a more diverse set of options available to us. We need to have some more advanced techniques to provide a comprehensive evaluation of the output. So that's where we're going next. At a high level, we're going to talk about benchmarking, human-in-the-loop evaluations, LLM as judge, automated tools and frameworks, and then online evaluations. So benchmarks rely on standardized data sets to test LLMs. Basically, what we're doing is we're providing the models with specific inputs and comparing their outputs to correct answers. So this is a way to, again, objectively evaluate their performance. And this ensures that we can really evaluate a lot of LLMs consistently and reliably on a specific task. So these benchmarks usually have like a specific aspect of LLM performance that they're interested in. So it might be factual knowledge, math abilities, reasoning skills, language understanding, etc. So each one is going to focus on different features. And so we might want to use many depending on what we're trying to do with our model. There are some notable benchmarks that you've probably, you may have seen or will see in the future. So we have like GLUE, which evaluates grammar, paraphrasing, text similarity, just general language understanding. HelloSwag, which is used for the model's ability to complete sentences logically. Truthful QA, so the truthfulness of model responses. And then MMLU, which is multitasking across various domains. So as you can see, each one kind of has their own specific thing that they're looking for. We also have a lot of tools that allow you to use many benchmarks all at once. So rather than doing just one benchmark at a time, you could do a test suite across many benchmarks and to assess the model's ability to perform across different tasks. So we have like Big Bench, OpenAI evals, Parl AI, tons of different stuff. And yeah, they all allow you to test across various domains. So they can be a good way to quickly evaluate an LLM against standardized metrics, but for many different specific tasks. Another very important evaluation method we can use is just human judgment. So this involves using human reviewers to assess the outputs of LLMs for quality, relevance, and appropriateness. These are qualitative assessments, and these are really good when we care about nuance, context, and things that the automated metrics might miss. Human evaluators can also provide feedback on how well the model aligns with real-world expectations and requirements. So this is really useful when we care about bias and ethical concerns. So for example, human evaluators could assess the quality of responses generated by customer service chatbots and make sure that they're polite, for example. That's not something an automated metric is going to be able to find. Or if they're contextually appropriate, helpful, that kind of more almost subjective, but like, when you know it because you're a person, that kind of thing, that you can't measure with something like Perplexity or Blue. So the human annotators might look for things like the correctness of the text, how well the content addresses the context or the query that they made, readability, grammar, decision-making process. So if I say, think it through step by step, which is a common thing to do with an LLM prompt, it would say, like, did that decision-making process make sense? If it avoids inappropriate language, and then again, if it aligns with human values and social norms. So this all comes with the caveat that human evaluation has its own set of challenges. You need to think about the number of evaluators, clear instructions, annotator expertise, tons of stuff like that. And then, of course, it's not the most scalable option. So what can we do instead? Another approach is to use LLMs to evaluate each other. In this case, an evaluator LLM judges the generated text based on whatever kind of thing we want it to care about. So this could be linguistic qualities, relevance, adherence to given prompts. So this is kind of what we were talking about before with kind of generating generating labels for your data. You could also use an LLM to judge the outputs of another LLM. This can be a really good tool for preliminary assessments, also really good for continuous integration during deployment. So someone asked about monitoring your LLM in production. You could have another LLM do that. Scalability might be a thing, but that's another option. And then large scale evaluations where you would need like a whole army of humans, and it's not really practical. So the evaluator LLM can either be trained using prompts or fine-tuned to perform these specific evaluation tasks. So maybe it's going to score, for example, let's say the fluency of a text, or maybe you're trying to teach an evaluator LLM to find factual inaccuracies or find hallucinations. So an example application might be performing consistency checks. So like ensuring responses across different examples remain factual and they don't contradict like known information or previous answers. So you could have, just to step back, you have your LLM that's your worker LLM. It's the one you want to actually be doing the responding. Then you have a second LLM, your judge LLM, that is checking the outputs of the first one. And this is a way to kind of balance scalability and quality. So it's a little more nuanced, of course, than using automated metrics, but it's way more scalable than humans. So it's a bit of a balance, but of course, then you also have the pros and cons of both of those as well. Another thing to keep in mind is LLM judges are not great with things like sarcasm or irony. It's not going to work as well as it would if you had a human annotator. So depending on the context, this can be a super useful tool. I would say LLM as a judge is a really great option if you have kind of a low stakes application, but you want to evaluate a lot of data. So for example, I have previously built an application that summarized summarized user information, and then a human would evaluate that and make decisions based on it. The human has access to all of the original data. So it's pretty low stakes because the human can say, this summary doesn't make sense. I can see it right here. That's fine. So this is a way to really quickly generate some outputs, but in a low stakes situation. So that might be a good time to have an LLM as judge say like, hey, your summaries are good or not, because I know that a human is going to take a look. Versus I wouldn't necessarily rely just on LLM as a judge for something like a loan application, or something that's really like kind of critical. In that case, you would definitely want to have humans in the loop. So here's an example. Meta recently introduced something they call the self-taught evaluator, which is cool because it combines LLM as judge and also this machine-generated gold standard data set, which is neat. So basically, we are creating a more accurate and reliable LLM as judge by iteratively improving judgments without any human labeled data. So the LLM is generating synthetic training data, which it uses to make itself a better evaluator over like this iterative process. And I can send the paper if you're interested. I'm not going to go into too much detail, but basically just to say, there's a ton of opportunity here to kind of use the strengths of LLMs to allow us to scale up our applications in a really meaningful way. And then this judge is cool because it can be used in lots of different contexts. So it can be used for evaluating things like summary quality, correctness of answers, and text classification, overall alignment with human preferences, all that kind of stuff. So I'll just send the link just in case you want to check it out. It just came out a couple weeks ago. Yeah. So another way to scale is to use automated tools and frameworks, which I've talked a little bit about so far. So this allows us to process large volumes of data and generate our evaluation metrics really efficiently. So this automation is also going to allow us to have really consistent evaluations. This reduces the variability that might be introduced by human reviewers. Really important when you have a large scale deployment to have a very specific set of steps that you follow for evaluating your model from end to end. So there's tons of different tools. Some examples would be Prompt Flow from Microsoft. We have Vertex AI Studio from Google. Amazon Bedrock has one, and many more. Weights and biases, Langsmith, deep eval, all kinds of stuff. So these are definitely ones to check out if you have a large scale deployment and you want to be able to run a bunch of different tests on many different things we've talked about. So maybe you want to check out different automated metrics and benchmarking, and you have a bunch of stuff you're interested in. These tools can kind of create a pipeline for you so that you can evaluate and compare models for many different use cases using many different kind of methods. Once we're confident in our LLM's performance offline, we can then run A/B tests to gather user data, which is really, really super duper useful. So in this case, we are automatically going to run different versions of our model in production. So we have our A, B, different variants, like a standard A/B test. Then we would do things like maybe add a survey like I was talking about, or you could just even rely on user data like whether they bounce or whether they engage, like how long they engage with the model, whether they end up, searching around a bunch afterwards, tons of different things so you can get direct and indirect feedback and then compare. And then this is really going to reflect the complexity of real world usage and get super valuable feedback to figure out if your model is performing well for the actual end user, which is clearly the most important thing. Before I go to the case study, I see one question here that I didn't get to yet. So how to handle hallucinations and considerations of ethical responses from the LLM. So hopefully you have been working with an LLM that has already considered this in training, just as a first step. We'll actually see a little bit how OpenAI did that with GPT-4 in the case study now. So theoretically, at this point in LLM evolution, if you're using one of the big name models, it shouldn't be a major issue. Especially something like Anthropic or Titan. I've even had situations where the models are trying to be so good, aligned with human values. They're trying not to have any kind of problems socially, that they won't respond to a prompt that has a curse word in it. And sometimes if you're working with a transcript, I work at Twitch, sometimes people curse, and so even in that case, there's such strong guardrails. So I think it's probably not something to worry about a ton if you're using one of the bigger models. But also, generally, like I was saying, human feedback would definitely be the best way to double check that. Yeah, so I would say probably humans as your gold standard, and then you could also maybe work with an LLM as judge framework or something like that. Benchmarks will also have plenty of opportunity to check for ethical responses, responsible AI, all that kind of stuff are definitely available in various benchmarks. So lots of options. Another question here. So do we have to worry about security or vulnerability in LLMs? Yeah, for sure. You definitely do. So it depends on exactly what you're doing and what kind of data you're using. So if I was building an application at Twitch, for example, I would not be able to use any LLMs that were not on AWS, because the model, or excuse me, not the model, but the API is usually going to send the data and then it's going to be stored on someone else's server, and that might not be aligned with your privacy for your particular customers. So I couldn't use an OpenAI API for something I work on internally. So you definitely have to think about that. The data you're sending is almost always used by those companies for, training or evaluation. It's not necessarily nefarious. It's just, we have privacy considerations we have to think about. And then similarly, if you have users sending their data to your API that uses an LLM, you have to have all of the normal security considerations with that. If they're sending personal information, you have to make sure that's protected end to end. But that's kind of more on the software engineering side of things. Okay, so how did OpenAI evaluate GPT-4? They used a lot of these concepts that we've talked about. So as I'm sure most of you know, GPT-4 is a large multimodal model, that's hard to say, capable of accepting both image and text inputs. So you could upload a picture, you can ask it to generate images, all kinds of stuff. and it usually has text outputs. So it's sometimes less capable than humans, but it's often really impressive, super close to human level performance in a variety of professional and academic benchmarks. I use it every day, super helpful for me. So starting in August of 2022, quite a while ago, OpenAI recruited external experts to do a qualitative evaluation pass. So before any of the quantitative stuff, they really did a lot of qualitative work. So they were adversarially testing the GPT-4 models. So this was stress testing, boundary testing. Boundary testing is where you do extreme inputs, like really short, really long prompts, super confusing stuff that you're just trying to find edge cases and test how the model responds to that. And then also something called red teaming. Red teaming is a structured effort to find flaws and vulnerabilities in a system. So yeah, they were specifically trying to find issues with the model with kind of this iterative approach where they had some initial hypotheses on high-risk areas, and then they would test and adjust and incorporate new mitigation and controls. They did lots of different rounds of red teaming to refine the model over the course of several years. And people who were involved with this came from various different fields. So they had folks from fairness, cybersecurity law, alignment research, all kinds of stuff, very cross-disciplinary. And then they used this feedback to identify potential risks and provide insights for further safety research. And then they also used it internally. So they had these external experts, and then they also just used it a lot internally to see how well it worked for things like support, sales, content moderation, and generating code. This internal testing provides more insights into the model performance, and so that can give some more ideas for future improvement and refinement. In addition to the qualitative evaluations, OpenAI conducted internal quantitative evaluations as well. So this is particularly relevant for kind of those high-risk areas like hate speech or something like self-harm advice. They would want to make sure that the model is not generating harmful content. So they used automated evaluations to compare different model checkpoints on safety relevant criteria. The quantitative evaluations included running the model through a ton of tests that were designed to specifically try to trigger these violations. So they would try on purpose to have a prompt that would get the model to say something like hate speech or harmful advice, just something that the model should not respond to. And so then they were able to analyze how the model responded to those kind of prompts and see if it did end up generating such content, if you could like find a way to make it behave poorly. This was used to identify potential weaknesses and again, areas where the model needed further improvement. They used automated evaluations again as a whole kind of framework for streamlining this process. So they automated all of these tests that we talked about so that they could compare different model versions and checkpoints and make sure that they were consistent and objective in each of the progress points that they were checking. And then also made it easier for them to iterate quickly and refine the model. OpenAI evaluated GPT-4 on a bunch of different benchmarks too, including simulating human-designed exams. So they used publicly available exams and practice tests, and like the bar for being a lawyer, then medical exams, that kind of thing. And so they would basically have the LLM take the exam and then write up the model's score based on what the known correct answers were. And this would give kind of like an assessment of how GPT-4 compared to human level behavior on these kind of important academic setting exams. They also use traditional machine learning benchmarks using few-shot prompting. So they basically gave the model a few examples of the correct answer and then said, hey, given these correct answers, what would be the correct answer for this next prompt? So they used a couple of the benchmarks that we've talked about. So they did the massive multitask language understanding, HelloSwag, human eval, and truthful QA. So like truthful QA, for example, as a reminder, was like, can the model distinguish between factual information and like deliberately selected incorrect statements? So this is really good when you care about hallucination in a model, because we need to make sure that the model is not producing anything that's nonsensical or untruthful. So if you're worried about hallucinations, something like truthful QA could be a really good benchmark to use. GPT-4 was also assessed in other languages. So they translated MMLU into 24 other languages using like a Microsoft Azure Translate service. And then you could get kind of like an initial vibe of how the model would do in other languages, though it's definitely focused on English still. They also did some benchmarking on vision. So they did some academic vision benchmarks, which are really similar to kind of the same idea of what we were talking about before with like truthful QA and HelloSwag. So for example, they would check if the model can answer questions about images, or if it can understand the text within images, generate charts, diagrams, how well the model can answer questions about documents, all kinds of different things. Then they were able to also use this to discover new tasks that the model can tackle. So this gives you ideas for future ways to improve the model and expand on it as well. Like I was saying, all of this was done using an automated system, and that system is OpenAI evals, which is open source. So you can play with it if you want. This is a really useful tool for continually tracking performance and identifying model shortcomings, that kind of thing. You can create custom benchmarks. You can have custom metrics and streamline them all into a pipeline. It has existing benchmarks in there as well. So yeah, this tool is available. Like I was saying, if you're curious, you can go get hands-on experience with it. Open source, it's free. Are there any questions before the last section? Okay. So now that we have an understanding of what's happening now in industry, let's talk about some challenges and possible future directions for the field. So one of the most significant challenges in LLM evaluation is addressing these ethical issues and biases. We've had a couple questions about that. So since LLMs are trained on large data sets that reflect human language and behavior, of course, they are also going to potentially learn those harmful biases and perpetuate them. So ongoing research is still being done into the best ways to mitigate this. This is something that is top of mind, as you could see in the OpenAI evaluation framework. They had experts who are concerned about this. This is something that's ongoing, but it's still something that we could definitely improve on. There's also the issue of computational resource demands. So this can be a barrier for organizations and researchers, and it also actually has an environmental impact just because of the extreme amount of energy used. Overfitting is a common issue. So especially in slightly older versions of these models, overfitting to popular benchmarks, but failing to generalize to new data, like when you're interacting with a user, was a big problem. So part of the reason that this can happen is something called data contamination. So it could be that the model was trained on benchmark data on accident, like somehow the benchmark data got into the training data, and so the model does super duper well on the benchmark, but then not necessarily super great when it's just being given a general prompt from like a normal person. We also need some more creative metrics. So like we were talking about, blue, rouge, perplexity, things like that. They might not capture nuance, creativity, diversity, especially in open-ended tasks. So researchers are working right now on more nuanced evaluation metrics for things like emotional intelligence and cultural sensitivity, which is definitely an interesting field. I'm curious to see how they're going to, what they're going to come up with. So that should help us get a more holistic understanding of LLM's capabilities. Lastly, this one's really important in my mind. So the rapid pace of innovation in LLMs needs to be balanced with appropriate regulatory frameworks to ensure they are safe and used ethically. So policymakers and industry leaders need to be able to collaborate with industry, collaborate together to develop these kind of standards and guidelines to address risks and challenges, but also allow for innovation to continue. So this includes setting benchmarks around things like transparency, accountability, data privacy, user protection, but also still having an environment that encourages technological advancement. So this is going to be an interesting challenge. Some things that we might be able to do to address these challenge are use multiple evaluation metrics. So if we can incorporate a variety of metrics beyond just blue, rouge, perplexity, maybe something around human alignment, then that can be really helpful. Similarly, having humans involved can be really useful. Even though we can scale with LLMs, we always want to make sure that there's some level of human involvement, at least at the early stages where we're like training the LLM as judge. We want to make sure that we have diverse reference data. So curating data sets that cover a wide range of acceptable responses and encouraging contributions from diverse sources can really help with the quality and coverage of the reference data. We also want to make sure that there's real-world evaluation. So we aren't just looking at how the model performs in kind of like a closed setting when we're benchmarking, but just in practical real-world situations. And make sure that we are making sure about robustness and security. So we want to make sure that the LLM is safe against adversarial attacks. This is an ongoing research area and going to be something that's really important to make sure that our models can't be easily like kind of deceived or manipulated, especially important when we have sensitive applications. So what can we look forward to? Like we talked about, as LLMs continue to evolve, there's a need for more sophisticated and nuanced evaluation metrics, which are going to be coming soon. I'm really curious, like I was saying, about like emotional intelligence, cultural sensitivity. How are we going to be able to actually measure those things? That's going to be a super interesting field of research soon. It's also going to be interesting to see more real-time and adaptive methods for continually assessing model performance. Right now, LLMs are very slow, very expensive. As the technology improves, that might change. We might have a better ability to learn and grow in the moment. This will also help us identify issues quicker and hopefully improve the overall reliability of our models. And another promising direction is the development of LLMs that can generalize across multiple domains and tasks without extensive retraining. So this could be something that requires new benchmarks and methodologies that tests the model's versatility and adaptability. This can help us to achieve like robust cross-domain performance, which is going to help us expand the applicability of LLMs and make them more useful in a wider range of scenarios. So that's everything I have today. If you have any questions, I will hang out.
Hey, hi, Marina.
Yeah.
Thank you for this wonderful session, actually. It was really well-rounded in terms of covering all the concepts as well as the demo session. Just wanted to have a quick call out over here. And I would like to thank all the attendees for attending the session and making time for this session. Just in case if you like the session and if you have, if you want to cover similar concepts as well, we are covering this in our a host of different other courses that we have at Interview Kickstart. So just in case if you are interested, please get in touch with the Interview Kickstart program advisors, and we can take it forward from there. Yeah, that's it from my side as well. Thanks, Marina. Thanks for your time.
Thanks, everybody.
Have a good day.